You're listening to the Modern Mainframe, BMC's intelligent C optimization and transformation podcast, covering the latest trends and issues in the mainframe, and how BMC AMI solutions can help you make change your competitive advantage. Hi there, welcome to the Modern Mainframe. I'm Matt Dallaire. Today we'll be talking about mainframe performance testing. Joining me are BMC Senior Product Managers John Dannenberg and Kevin Corbett, and Lead Product Manager Mark Schettenhelm. John, Kevin, Mark, thanks for being here.
Always a pleasure.
Thank you, Matt.
So we've had several episodes of the podcast, as well as ebooks, blogs, and other content about automating mainframe testing. But these tend to concentrate on the functional testing of code, detecting bugs and defects. John, what is performance testing and how is it different from functional testing?
Performance testing takes a look at different things than what functional test does. Functional testing looks at your output, your expected output, whereas performance testing will look at loading, speed, and other things. So as an example, response time. Response time is considered performance. Customers will have kind of a negative response to slower times. So you want to make sure it works. The big thing are batch jobs where you have your SLA. You need to have batch jobs perform in a timely fashion. If the job's finish and they take longer, but still produce the same output, you're just driving up your costs and risking your SLAs not being met. You can also do load testing. Load testing can also be considered performance. So you want to make sure you can handle multiple users, say hundreds of users, even thousands of users, and a number of transactions executing against your application to make sure there are no bottlenecks.
I think John touched on several points that are important aspect of the performance testing. Again, as we mentioned, it's not testing the functionality that you should have done already, and I know that you have. But now we're looking at, can the system perform, under a variety of different workloads, various scenarios, and measure its response time, throughput, and resource utilization. John's touched on all those, but this is a totally different type of testing, extremely important.
So Kevin, how can performance testing and measurement benefit customers and the company?
Well, there's a number of things that it can benefit the company on. One, John mentioned it, the response time. If you're processing transactions, banking transactions, for example, and it's taking seconds, which seems like it's fast, but yourself when you get on your mobile phone to check your balance of your checking account, you want it now. So it's very important that you meet the expectations of the users, your customers. I use banking as an example in a mobile app, but it can be anything. It could be somebody sitting down at a keyboard and typing in some information to update a data set or something. All of those things need to perform well. They need to be able to scale. We need to be able to make sure that we can process what we expect the workload to be, but we also need to make sure that we're testing to ensure that if that peaks for some reason, like maybe around the Christmas holidays and people ordering from certain companies, that demand goes up. We need to make sure that the applications can handle those kinds of things. That's an example of, from a retail point of view, but it's the same thing if you're working with a payroll application or any other business application. You need to make sure that it can handle peak and not fall over dead. We want to make sure that also complying with regulations. A lot of industries, healthcare, finance, all have certain requirements that an application needs to meet. So performance testing is necessary to ensure compliance. That's something that most developers don't really think about, but as a project team, when we were defining what the tests need to be, those things all need to be taken into account.
So Mark, what are some of the problems that might occur if performance testing is not done before code is promoted to production?
Fortunately, if you have a system set up to test before it goes to production, that's going to avoid having the problem in production. So that's good. The problem with that is that could be way past when the developer actually made the change. They may make their change, then it goes to your regression testing, and integration testing. So all that testing goes along, then it's finally getting ready. If you find the issue there, then it's identifying where it is and going back to that developer who's gone on to other tasks. And so they have to get back into it, think about it, make the change, and then you start that whole cycle again. That change has to go through all those steps. It's far better if it can be done as soon as that change is made, detect performance issues, correct them while they're working with the code, then it'll perform well, and then it can go through all those other stages. It saves a lot of time and makes it a lot better for the developer. It's a better developer experience to handle the issues as they come up while they're developing rather than getting pulled off something to fix it later.
And Matt, this ties right into your opening about all of the talking we've done about shift left on your application testing. That's absolutely imperative. This is no different. You have to shift this performance test earlier, as Mark's talking about, and do it periodically throughout the development cycle. And as John said earlier, it depends on what types of changes have been made, but on some kind of a frequency, you need to be testing early in the development process and as you go along. And then absolutely, before you actually toss it over the wall into production, you want to make sure that you've run that again and gotten it. I want to go back and re-stress what Mark said, that you need to find performance problems early. John mentioned DB2 as one of the examples, but it could be other things as well that are getting in your way. Perhaps, there's some constraints on your system that's causing problems. And that's where monitoring your performance test, not just looking at how long did it actually take to run, but monitoring the entire application from end to end. Can I help identify and pinpoint I have a problem in DB2, or I have a problem not necessarily in DB2, but with my DB2 SQL perhaps, or I have a problem that the CPU is not giving me enough of the bandwidth that I need or the power that I need to actually do the work because of those peaks that I mentioned. So it's extremely important to start working that in early so that we can identify any bottlenecks, any issues, and make an attempt to correct them.
Right. And what I like to think of it is when a developer's putting in an enhancement to their code, they're usually adding more logic rather than taking it out. So naturally, things will take longer. It will perform a little worse because there's a little more thinking going on. So when a developer makes that change, they should at the same time look at things like their DB2 calls to see if they can make them perform better and try to balance those effects so that they actually leave things better and not worse as far as performance when they add new logic.
Yeah, that's a good point because, we may identify something through our monitoring that, it indicated that DB2 had a problem and say, oh, okay, we'll go out and make sure it's using an index. That doesn't necessarily mean anything. So you have to go through the test again. This is an iterative process. You don't just run it once and be done because you identified something and you've resolved it. Once you resolved it, you need to run it again because there's a good possibility you could have introduced additional performance issues.
But catching them there rather than later is much, much better overall.
Right.
I think that's one of the – go ahead, John, sorry.
I was going to say, with Mark's point there, the worst case scenario is some code gets checked in, but it might be, say, a quarter-end application or a year-end, so it may not get caught right away. And like Mark said, other code has gone in. So now you've got to identify that code and pull it out. We did have, one of our customers did follow this process, and they had a program that went from 20 minutes to 2 hours. And they did the performance measurement on it, and they identified that the developer missed putting a period in. So they had a perform load statement, and they ended up reading a table every single read, a DB2 table, and where they only needed to do it once. So just a simple period can cause a major effect in performance.
I think that's a great point. I think that one of the things that we need to try and get across is that this is, as I said, it's an iterative process. It's got to be repeatable. And you should be looking for tools that you use in your functional testing which can also then, in test cases that you've created to do your functional test, become the same test cases that are part of your performance, but perhaps expanded to include more transaction volume or things such as that, peak loads. But again, it should be automated. This should not be a manual process. And I think traditionally people have thought of it as a manual type of a process, which may be why they always put it off to the end. But it's not manual. You take whatever kind of scripts that you're using to run your functional test, you include them in your performance test. Products generally will give you an ability to say, this is a performance test, which activates some other features. I mentioned the monitoring. Typically, a functional test isn't going to monitor those things that we were talking about as far as DB2 and CPU and things like that. Performance test will, and it will kick off some different monitoring and provide you reports on where those bottlenecks are. But that's all automated. All you have to do is review the output. So I think that's an important aspect of performance testing and getting people to understand this is just another automated test. And if you've done it, if you've built it correctly, then it can be included in those nightly integrations, continuous integrations, or weekly, or whatever you promote to a certain level before production. That automatically kicks off not only your functional testing, but then your performance testing as well.
So we've talked about incorporating it regularly, which obviously leads to automation as being a great way to do that. Mark, does the developer mindset or the developer culture need to change to accommodate performance testing?
It does, because they may be thinking, oh, that's something we do at the end. So you have to let them realize that it can be done sooner and go through the things we've talked about and explain to them that it is better. So often developers think of the status quo. That is just the way things are. And of course, things come up later and I get disrupted and go back. But say it doesn't have to be that way. It can be better. So paint the picture of how it will be and that things are available for them. And that enables the culture. And then I think they'll be eager to adopt this and work in a better way.
And I think that if you have product management and product owners express that in their user stories. So when new code is being developed, it's like, consider this. Consider the performance aspect. It's one thing to get your output correct, but we want it in a timely fashion. Like Kevin said, maybe we have a time where we say, okay, it's got to be within this metric of performance of the previous version, right? We've done that ourselves here where we've made some big code changes and we run baselines just to compare it. And sometimes it will increase because you're just doing more work. But then at least you know why. You're looking for those unexpected negative effects.
There's another part of performance testing that we haven't really hit on. We've been talking about developers are making changes to an application, and that's extremely important. But what about operating system changes? What about a new version of DB2, a new version of IMS, a new version of the operating, ZOS? You need to make sure, even if you have no development going on, you need to run those performance tests to ensure that you're going to perform just as well with those new versions as you did with the old, or better, hopefully, because of performance improvements in those products. But it's important to make sure that even if we're not in a development cycle, if a new release of something comes out that you work with, you need to make sure that you're still performing at least the level you were before.
That's a really valid point, Kevin. We've had some customers with IMS say, for example, they create a new IMS region with the newer release. And they mirror, so they're going to kind of mirror it to make sure everything's working fine, but then they see a performance is negative. And it might just be some tuning the IMS DBA needs to do to tweak a couple of options. But at least they'll find out before. So it's a good point, Kevin. It's really an entire dev and ops together. So, you don't want to blame developers for something that was an operational systems program that changed or parameter that was different than the other one, right? Same thing with DB2 and Kix. There are a lot of things that can affect it. You get a new box, you get a Z16, you've got to run it. You get the new operating system, you have to run it.
And this all goes back to understanding what it is you need to, what kind of performance testing you need to do. You need to understand that environment, which we talked about. This is kind of tying back to that. Hopefully you have that environment already built because you're doing your performance testing. But like I said, even when you're not making any changes, if there's any kind of a change, CICS, DB2, IMS, ZOS, anything else that you happen to connect with, performance testing needs to be rerun. And it's not an issue, especially if you have it automated. You just have it kick off, and away you go. I know we make it sound simple, but there obviously there's legwork, upfront work that you need to do to get that performance testing the way you need it to be. But once you've had it, I think Mark said this earlier, once you have it, it's just a matter of running it and evaluating.
So
I know we make it sound simple, but there obviously there's legwork, upfront work that you need to do to get that performance testing the way you need it to be. But once you've had it, I think Mark said this earlier, once you have it, it's just a matter of running it and evaluating.
So besides developers, who should be interested in performance testing?
I think a lot of times, we've been talking about the developers. Believe me, the developers are extremely important here. But it's not just developers. John mentioned it's the product managers and product owners that need to be keenly aware of everything that's going on, whether you have an active project or not. I've said that many times, but it's important for us to understand what's going on. And here at BMC, basically everybody in the organization is alerted when there's a new version of ZOS going to come out, or a new version of DB2 or IMS or whatever the case may be. And typical developer may not care about that, but the product owners need to care about that so that they can ensure that we're preparing for it. And the first preparation is, let's run a performance test. Let's run our functional tests against it. Let's make sure we're still performing and functioning the way we expect to. We review changes, but it doesn't mean we're going to catch everything.
Yeah, it's a full team effort. Basically, we talked about the operational people. We got the systems people. You got the developers. You got product management. You've got simple things like, for example, a performance issue could be maybe you have a vSAM file and you have your index portion on a DASD that has high activity. So now you're competing against other applications. So, you've got to look at things at a system level too. So it's going to help developers expand just beyond coding. They're going to understand their environments, the whole logistic operations. And I think, as part of that, then they're going to then see how customers view the product, the application. And they'll have more vested interest in making a nicely tuned application versus just coding something and throwing it over the wall.
So what do teams have to consider? What are some of the elements of performance testing? How is it done?
So some of the elements of performance testing would be monitoring. So taking a look at your activity, and you can do that through SMF data to identify high CPU applications, jobs, and modules. The idea then is tag a couple of those, and this is for something that's already in production, say, to identify to try to tune. You already have some customers complaining about performance, so that'd be a great area to start with. And then you start taking your measurements. So start doing performance measurements. Start identifying code. Perhaps it's I/O. Perhaps it's DB2. We got to find out where those bottlenecks are. And there might be more than one. So we have some customers, they'll take one approach. They'll look at COBOL. Okay, let's look at the COBOL. Let's look at the I/O usage. How many opens and closes are we doing, for example? Do we need to do them maybe once at the beginning, once at the end? If you have them in the wrong spot, you're repetitively opening and closing files. Your program works fine, but something like that, through the SMF data and through measuring, you do some application performance measurements, you can catch these things. And that's where they have to have some knowledge of what the product does, how it works operationally. And I think, that helps them to identify bottlenecks too. And if you've got one, say, for example, you've got a legacy application from, let's say 30 years ago, if you find one pattern in there, the chances of that pattern exist in the others are pretty high. So that kind of gives you a nice launching board to go back. And when you make those changes, you can actually run some performance measurements and then do a compare against what you think will improve it. And once you get that confirmation, then you start moving forward and start rolling it out to the other applications.
That's a good point, John. I think that, people looking for a tool that they can use to help them with their performance testing and their functional testing, they should really be combined. But that performance testing aspect of it really needs to kick off that monitoring. It has to be included, and that way developers don't have to think about it. It's just, I'm running a performance test. It's going to do a measurement, and I'm going to have results to look at. They don't need to understand necessarily everything that's been put into building that performance test. They just need to be able to understand that what it's doing and what their responsibilities are once it's completed. I think another thing that I just thought about that's kind of important is that, and I think, John, you touched on it, is the tests that we run, have to mimic the real world usage patterns and workloads. So there's got to be an understanding. The common developer may not understand exactly how the product is used and how frequently it's used. So having some way of understanding what's the usage of my product, and being able to say, okay, gosh, that feature is used N number of times an hour or whatever the case may be. And we need to make sure we understand that so we can build the environment and the tests to mimic that workload, whatever that workload is.
Well, it sounds like performance testing is a really good example of the value of DevOps, of the collaboration, the transparency. It's kind of a microcosm, if you will, of the value behind implementing DevOps.
Absolutely. We've talked over the years about all the various types of testing. You've got unit testing, functional testing, integration testing, system testing. Performance testing is just one more of those phases of testing. Traditionally, as we've already talked about, it's been put off to the end because, you don't test the performance at the beginning because why would you? We don't have anything yet. Well, yeah, that's why we said, let's move that forward. Let's move that left so that the developers are testing more frequently from a performance standpoint. So we're catching those problems earlier. And Mark, I think all of us have actually made that point a couple of times. But
right.
Mark,
and once you have those things, you say, once you've set up your DevOps pipelines and you have them, then it makes it easier to do things like this. So where today you might say, well, I can't do performance testing that early. Once you have the pipelines in place, once you're doing your other testing, your functional and unit testing earlier, it's natural to just slide the performance testing in at the same time, and you get greater benefits. And if you haven't adopted the DevOps pipelines, this is another reason to do it. It builds a better business case for you to go and make that change.
It's good to have that business case to make the change, but it also gives you the ability to reassure your customers, whether they're external customers or internal customers, that you've done your due diligence. I've done all of this regression testing. I've done all this functional testing, and I've done all this performance testing. And oh, by the way, we improved performance with the changes we made, or whatever the outcome may be. You certainly don't want to go back and tell them, boy, we made that a lot worse. But that's again why you do it, because if you made it worse, then something we did was wrong, and you need to go back and look at it again and correct it.
So, John, do you have any final thoughts?
There's quite a lot here to digest. I think the big part is that, performance test isn't easy. It's not like functional test or unit test where you're just testing some code. You've got things outside of the code. the code and outside of the code all together. It's the whole operational aspect of your application. So, when we talked about the different people who are involved, some of the examples, Kevin brought up with creating system software. We've got product management involved. I think, we've got customers involved because it's their satisfaction that's going to basically say, hey, is your company making money or are you losing customers because you have bad performance? I've been on websites and I'll have bad response, like Kevin said. I don't know how many seconds it was, but to me it was like taking forever. I go on another competing website and it's almost instantaneous. It's like, well, who do you think I'm going to stay with, looking for things? It's the same thing with performance. You got financial institutions, you got customers who are expecting quick balances or a quick transfer of money. So, it's all about the customer performance. And then the other aspect too is you have tailor fit pricing. So you want to watch those MSU costs. So if you're needlessly executing code in an inefficient way, your MSU costs could be through the roof. By optimizing performance, you can reduce those MSU costs and then your monthly billing to IBM, or having to do an upgrade, for example.
Kevin, any final thoughts?
Yeah, kind of piggybacking off what John was saying. The whole reason for performance testing is, one, to ensure our customers are comfortable with the performance of our application. We've already demonstrated that it functions properly. Now let's make them comfortable that we're performing properly. That performance ties directly into cost, as John pointed out. That's a very important aspect, and we kind of only basically touched on it as far as measuring CPU and response times, and all those things factor into cost as well. So that's reducing cost. But I think that one of the things I'd like to get across is that everything we've talked about today, basically what we're saying is whatever tooling you're using, you should be able to utilize it for both your functional and your performance testing. They should kind of feed on one another, and they should be able to scale the tests that you had for your functional testing into that performance testing to give you the volume and transactions and things you need. It could be even number of users, right? So the tool should be able to do that. And also, from a performance perspective, it should automatically, if you have a tool that will take measurements, it should automatically take those measurements. We don't do that during functional testing because there's overhead involved, right? But during performance testing, that's when you really want to take those measurements and evaluate them to see if we have any of those bottlenecks. So if you're looking for tooling, you need to go out and find something that's kind of a all-in-one box type of a solution. I think that's an important thing because that also is going to then save you time and probably cost you less.
Mark?
I would say just do it. Just go in there, start small and then build big. Don't be overwhelmed. Don't think I can't do it. Just get in there and pick something, maybe a program that has high impact that you're concerned about. Start with that. If you have the pipeline, just add in a performance test. Just start on it. You'll see the results and then you'll get moving. But don't sit on the fence. Just jump in and start doing it, and you'll be glad you did.
Great point. Be agile. Just start and then build on it as you need to.
Mm-hmm. And it's a good point that you guys bring up. Kevin, you say you've got the tests already there in functional test. The unit test is looking at a unit of code, whereas performance test is looking at a scalability, loading, and times. Functional test is looking at your desired output has been met. So when you create performance tests, you have to create them with enough of an impact to get some of those metrics, some of the CPU, the I/O, the MSUs, in order to visibly see a difference. If you're only looking at things of fractions of a second, like 0.001, it's going to be real difficult to identify performance issues. And we do know when you start programs, there's a lot of overhead at the beginning. At the end, it's the guts in the middle. So if you have a small test and you scale it larger, you'll then get a better representation of the actual code versus just the overhead of loading up a program and opening up files. That's going to be consistent. So that workload in between is something important to consider.
All great points. I think we covered a lot of ground today. So, John, Kevin, Mark, thanks for joining us again.
Again,
Thank you, Matt.
always a pleasure, Matt.
Thank you, Matt.
I'll include some links in the show notes for more information on performance testing. Thank you for listening to The Modern Mainframe. We'll talk to you next time. Take care. You're listening to The Modern Mainframe, BMC's intelligent C optimization and transformation podcast, covering the latest trends and issues in the mainframe and how BMC AMI solutions can help you make change your competitive advantage.